Hey there guys, it's me, Miss S. Just moving on with our next unit of study. We're going to take those integers and rational numbers and we're going to take a little closer look at them. Remember, we learned about classifying numbers into several different categories, and we talked about real numbers. And remember, real numbers were all of the numbers, every single thing you can think of. Now, those real numbers could be broken up into two main categories, and those two main categories were rational numbers and irrational numbers. Remember, your irrational numbers were numbers that could not be written as a fraction and was a non-repeating decimal. But our rational numbers could still be broken down further into other subsets. So those subsets for the rational numbers were your integers, your whole numbers, and your counting numbers. So today we're really going to be focusing on the subset of the rational numbers. So remember, a rational number is a number that can be written in the form of A over B, where A and B are integers. But remember, B cannot be equal to 0. It has to be something other than 0 for it to be able to be a rational number. So let's review fractions quickly. You can think of a rational number as a fraction of a cake. If you cut the cake into B slices, your share is A of those slices. For example, when we see the rational number 1/2, we imagine cutting the cake into two parts. Our share is one part of those parts. So visually, the rational number 1/2 looks like this. There are three main types of fractions. We have proper fractions, and those are rational numbers where the numerator is less than the denominator. So remember, the numerator is the top number, the denominator is the bottom number. A proper fraction represents a number that is less than 1. It's smaller than 1. So with a proper fraction, you will always end up with less than a whole cake. So an example of a proper fraction is 4/5. If there were 5 pieces to that cake, that whole cake was 5 pieces, you took 4 pieces, you would not have a whole cake. You would have less than a whole cake. Now there are improper fractions, and those are rational numbers where the numerator, the top number, is greater than the denominator, the bottom number. So improper fractions can be rewritten as a mixed number, an integer plus a proper fraction. So an improper fraction represents a number that is greater than 1. So an example of an improper fraction would be 5/4. If we look and had a piece of pie or cake, and I cut it into 4 pieces, well, I'm going to need a whole nother cake there, a whole nother pie. Because if I'm cutting that into, I'm going to take 5 of those pieces. Well, I'm going to take 1, 2, 3, 4, 5. So I'm actually taking 1 whole plus 1/4 of the other. And when I'm simplifying, can always draw out pictures, but another tool that you can use is you can ask yourself, how many 4s go into 5? 1 4 goes into 5. Well, if I take 4 away from 5, that leaves me with 1 left. So I'd have 1 and 1/4. That's how I would rewrite it as a mixed number. Now with the last form of fractions, there are equivalent fractions. So equivalent fractions are two fractions that give the same numerical value. when they are written. So for example, look at the pie here. This pie is divided into 4 pieces. Well, if we just slice it right up the middle, we have 1 out of 2 pieces. However, if I cut that piece right along the middle again, I see that now I have 4 pieces, and 2 of the 4 pieces are being shaded. So the visual of 1/2 is equivalent to the visual of 2/4. And we can write out the prime factors of both numbers and the denominator of the numerator and the denominator and cancel matching factors that appear in both the numerator and the denominator. So if we look here, we have 2/4. Well, to make 2, we can take 2 times 1. 2 times 1 equals 2. To make 4, we can take 2 times 2 times 1. That equals 4. Well, when we're looking at this, the 2's cancel out, and then we're going to remultiply. We have 1 times nothing is 1, and 2 times 1 is 2. So 2/4 is equivalent to 1/2. So therefore, 1/2 being equal to 2/4, this process is called reducing the fraction or writing the fraction in its lowest terms. So reducing a fraction does not change the value of the fraction, but it simplifies the way we write it. When we have canceled all common factors, we have a fraction in its simplest form. So let's take a moment on example 1 and we will classify and then simplify the following rational numbers. So the first one here is 3/7. 3/7. The 3 is smaller than the 7. The numerator is smaller than the denominator. So I know that this is a proper fraction. I know that it's going to be less than 1 whole. Now the number 3, the only way to make that would be 3 times 1. The number 7, the only way to make that is 7 times 1. We can cross off our 1s. So 3/7 is the lowest, the simplest way I can write that fraction. If I look at the next one, my numerator 9, that is bigger than my denominator of 3. So I know that this one is an improper fraction. And this one, I'm going to ask myself, how many times does 3 go into 9? Well, I can figure that out. I can go 3 plus 3. 3 plus 3 is 6. Plus 3 is 9. So I did 3, went into 9, 1, 2, 3 times. So writing 9/3 and putting it as a, reducing it to its simplest form, I get the number 3. The last one here, if I look at it, 50 is smaller than 60. So I know that I have a proper fraction. And I'm going to look, see what they have in common. So I know to make 50, I can take 5 times 10. And to make 60, that's the same thing as 6 times 10. Well, both of them have 10s. I can eliminate those. So 5/6 is the lowest form, or when I simplify it. I can't make it any simpler than 5 times 6. So now we also talked a little bit about ordering rational numbers. So to order a rational number is to arrange them according to a set of directions, such as ascending, remember, which is the lowest to the highest, or descending, which is the highest to the lowest. And ordering rational numbers is useful when determining which unit cost is the cheapest. So let's give an example. For example, 2 cans of tomato sauce come in 3 sizes. They come in 8-ounce, 16-ounce, and 32-ounce. The cost for each size are 59 cents, 99 cents, and $1.29 respectively. Find the unit cost and order the rational numbers in ascending order. So remember, ascending is smallest to biggest. So we're going to take a look. The solution, we're going to use proportions to find the cost per ounce. So we know that 59 cents is the 8-ounce. So I'm going to take 59 over 8. And if I have a division problem. If I divide 59 cents by 8, I get 0.07375, and that's per ounce. All right, so I'm going to circle that. That's my 8 ounces, my cost per ounce. Now I'm going to do the same thing with my 16 ounces, and my 16 ounces cost 99 cents. So I've got my 99, I'm going to divide it by 16, then I get 0.061875 per ounce. We can just assume there is a 1 there. And we have come up to our last one, and we have $1.29, and that is for 32 ounces. So $1.29 divided by 32 gives me 0.0403125 per ounce. And that is my last one. So now we need to arrange the rational numbers in ascending order. So we're going to take the smallest, which, let me erase this here. We are going to take the smallest, which was the 0.043125, 0.01. And then the next one is our 0.06, 0.06, which is our 16 ounce. And then our 0.0735, which was our 8 ounces. So as we arrange them from smallest to greatest, we found the unit cost and we arranged them from the smallest to the greatest. So now let's look at example number 3. And in example 3, we are trying to figure out which is greater. Is 3/7 greater or is 4/9 greater? So to figure this out, we're going to begin by creating a common denominator for these two fractions. Which number is evenly divisible by 7 and 9? Well, don't really know which is evenly divisible by 7 or 9. Let's see here. So when in doubt, we can always take the two numbers. We can take 7 and 9 and multiply them. In this case, 7 times 9 is 63. And whatever we do to the bottom, if I multiplied the bottom by 9, I have to multiply the top by 9. So I need to do 3 times 9, because it took 7 times 9. And then for the 9 to make 63, I multiplied that by 7. So I got to multiply the top one by 7. So here I've got 3 times 9 is 27. When I figured out 4/9, I have 4 times 7 is 28. 9 times 7 is 63. So because 28 is greater than 27, 4/9 is bigger than 3/7. So let's take a moment. We're going to watch this video here by Khan Academy, and it's going to give us a little bit more information on ordering expressions.
Welcome to the presentation on ordering numbers. Let's get started with some problems, and I think as we go through the examples, hopefully you'll understand how to do these problems. So let's see. The first set of numbers that we have to order is 35.7%, 108.1%, 0.5, 13/93, and 1 7/68. So let's do this problem. So the important thing to remember whenever you're doing this type of ordering of numbers is to realize that these are all just different ways to represent. These are all a percent or a decimal or a fraction or mixed numbers are all just different ways of representing numbers. And it's very hard to compare when you just look at it like this. So what I like to do is I like to convert them all to decimals. But there could be someone who likes to convert them all to percentages or convert them all to fractions and then compare. But I always find decimals to be the easiest way to compare. So let's start with this 35.7%. Let's turn this into a decimal. Well, the easiest thing to remember is if you have a percent, you just get rid of the percent sign and put it over 100. So 35.7% is the same thing as 35.7 over 100. Like 5%, that's the same thing as 5 over 100. Or 50% is just the same thing as 50 over 100. So 35.7 over 100, well, that just equals 0.357. If this got you a little confused, another way to think about percentage points is if I write 35.7%, all you have to do is get rid of the percent sign and move the decimal to the left 2 spaces, and it becomes 0.357. Let me give you a couple of more examples down here. Let's say I had 5%. That is the same thing as 5 over 100. Or if you do the decimal technique, 5%, you can just move the decimal, you get rid of the percent, and you move the decimal over 1 and 2, and you put a 0 here, and it's 0.05. And that's the same thing as 0.05. And you also know that 0.05 and 5 over 100 are the same thing. So let's get back to the problem. I hope that distraction didn't distract you too much. Let me scratch out all this. So 35.7% is equal to 0.357. Similarly, 108.1%, let's do the technique where we just get rid of the percent and move the decimal space over 1, 2 spaces to the left. So then that equals 1.081. So we already know that this is smaller than this. Well, the next one is easy. It's already in decimal form. 0.5 is just going to be equal to 0.5. Now, 13 over 93. To convert a fraction into a decimal, we just take the denominator and divide it into the numerator. So let's do that. 93 goes into 13. Goes into 13. Well, we know it goes into 13 0 times, right? So let's add a decimal point here. So how many times does 93 go into 130? Well, it goes into it 1 time. 1 times 93 is 93. That becomes a 10. That becomes a 2. And then we can borrow, so we get 37. Bring down a 0. So 93 goes into 370. I think let's see, 4 times 93 would be 360. It'd be 372. So it actually goes into it only 3 times. 3 times. 3 times 3 is 9. 3 times 9 is 27. 27. So this equals, let's see, this equals, if we say that this 0 becomes a 10, this becomes a 16, this becomes a 2, 81. And then we say how many times does 93 go into 810? It goes roughly 8 times. And we could actually keep going, but for the sake of comparing these numbers, we've already gotten to a pretty good level of accuracy. So let's just stop this problem here, because the decimal numbers could keep going on. But for the sake of comparison, I think we've already got a good sense of what this decimal looks like. It's 1.138, and then it'll just keep going. So let's write that down. And then finally, we have this mixed number here. Let me erase some of my work, because I don't want to confuse you. Actually, let me keep it the way it is right now. So there's two ways. The easiest way to convert a mixed number into a decimal is to just say, okay, this is 1, and then some fraction that's less than 1. Or we could convert it to a fraction, an improper fraction, like, oh, actually there are no improper fractions here. But let's do it that way. Let's convert it to an improper fraction and then convert that into a decimal. So 1 and actually I think I'm going to need more space. So let me clean up this a little bit. There we go. Okay, a little more space to work with now. So 1 and 7/68. So to go from a mixed number to an improper fraction, what you do is you take the 68 times 1 and add it to the numerator here. And why does this make sense? Because this is the same thing as 1 plus 7/68, right? 1 and 7/68 is the same thing as 1 plus 7/68. And that's the same thing, as you know from the fractions module, as 68/68 plus 7/68. And that's the same thing as 68 plus 7 is 75/68. So 1 and 7/68 is equal to 75/68. And now we convert this to a decimal using the technique we did for 13/93. So we say, let me get some space. We say 68 goes into 75. Suspicion I'm going to run out of space. But 68 goes into 75 one time 68. 68, 75 minus 68 is 7. Bring down the 0. Actually, you don't have to write the decimal there. 68 goes into 68 goes into 70 one time. 1 times 68 is 68. 70 minus 68 is 2. Bring down the 0. 68 goes into 20 0 times. And the problem's going to keep going on. So, but I think we've already, once again, gotten to enough accuracy that we can compare. So 1 and 7/68, we've now figured out, is equal to 1.10. And if we kept dividing, we'll keep getting more decimals of accuracy, but I think we're now ready to compare. So all of these numbers, I just rewrote them as decimals. So 35.7% is 0.357. 108.1%, ignore this for now, because we just use that to do the work. It's 108.1% is equal to 1.081. 0.5 is 0.5. 13/93 is 0.138. And 1 and 7/68 is 1.10, and it'll keep going on. So what's the smallest? So the smallest is the smallest is right here. So this is, I'm going to rank them from smallest to largest. So the smallest is 0.138. Then the next largest is going to be 0.357, right? Then the next largest is going to be 0.5. Then you're going to have 1.08. And then you're going to have 1 and 7/68. So hopefully, actually, I'm going to do more examples of this. But for this video, I think this is the only one I have time for. But hopefully this gives you a sense of doing these problems. I always find it easier to go into the decimal mode to compare. And actually, the hints on the module do the same for you. But I think you're ready at least now to try the problems. If you're not, if you want to see other examples, you might just want to either rewatch this video or I might record some more videos with more examples right now. Anyway, have fun.
All
You're
right,
welcome.
so we are going to stop right here, and we're going to page on down. When you click on the CK-12, you are going to go page on all the way down, and we're going to practice some of this. So our problems that I want you to do, and they're found on that CK-12 in the Google Classroom. I'm going to have us, I want you to answer the following problems. I want you to do problem number 3, and we're going to do problem 3. I'm going to have you do problem 5, and notice for problem 5, you're going to have to find A, B, C, D, and E. So problem 5 has 1, 2, 3, 4, 5 parts to problem number 5. From there, we're going to do, oops, let me erase that real quick. We are going to move on, and I want you to answer problem number 7. And then I want you to do the problems 9 through 12. And that's where we'll stop. That'll be our assignment for tomorrow, 9, 10, 11, 12. And for 9, 10, 11, 12, you're going to place the sets of rational numbers in order from least, the smallest, to the greatest. So you're going to go from smallest to the biggest. And the easiest way to do this, again, is to convert each of those fractions into decimals. So show me the decimals that you get, but when you rewrite them, I want you to rewrite them as the fractions. So we'll stop there, and if you have any questions, go ahead and contact me or come into the Google Classroom, and we will make sure that we get your questions answered. All righty, well, have a good one. Good luck.